So we're going to pick up 6.3 where we stopped yesterday. We didn't get too far. So we talked a little bit about this, but if there's a matrix, then A times A inverse, or if there's a inverse matrix, then A inverse times A will equal I. That's not a line, that's I, which is the identity, the 1, 0, 0, 1. A little bit of notation stuff. So this -1, that's inverse. That's what we use. So that's like it looks like an exponent. So like a to the -1, but we would say a inverse. Okay. So only square matrices can have an inverse, but not all of those do. So that's what this statement here in red says. Not all square matrices are invertible. So the word invertible means has an inverse. So yesterday, we found an inverse by setting up that system of equations. Like we had to solve for the variables inside the A, B, C, D. And we had two different systems of equations we had to do. There's a shortcut, like a formula we can use to bypass all of that. So here's the formula, and this is something you will want to memorize for your test. So this is for a 2 by 2 matrix. So you'll multiply the diagonals, A times D and B times C, and subtract. So AD minus BC, it's 1 over that value. And then this is like just a special matrix that helps us find the inverse. So to get that special matrix, you switch A and D. So A and D switch places, and then you do the opposite of B and C. So that's what those negatives do. So you would switch A and D and then do the opposite of B and C. So there will be an inverse as long as AD minus BC does not equal 0. Because if it equals 0, then you couldn't divide. 1 divided by 0, you couldn't do. So if that happens and it's 0, that's the cases that would not have an inverse. Okay, so let's do this example. So find A inverse for A. Okay. So A inverse is 1 over AD, so 2 times 1, minus BC, so -4 times 5, times that special matrix. So switch A and D, so 1 and 2 should switch places. And then do the opposites of B and C. So -4 becomes +4, +5 becomes -5. All right, now we just need to simplify. So this would be 1 over 22. You type in 2 times 1 minus 4 times, or minus -4 times 5, that should be 22. And then, so 1 over 22 is just a scalar. That's just a number we can distribute. So yes, we're going to get fractions, but we saw yesterday that our denominator was 23, that a lot of times the inverses do end up having fractions. And make sure you reduce. So 1 over 22 times 1 is 1 over 22. 1 over 22 times 4. If you reduce, that should be 2 over 11. 1 over 22 times negative 5 is negative 5 over 22. And 1 over 22 times 2 is 1 over 11. So this is the inverse of A. Remember how to check that. If you type in A and A inverse and multiply those together, you should get I, 1, 0, 0, 1. Okay, that's what an inverse is. Okay. All right, so that's a much faster way to find the inverse than going through all those steps that we did yesterday. So we look at this problem. This is asking me to use what I did yesterday, the matrix multiplication, and then you're setting it equal to 1, 0, 0, 1, and then solve this system of equations. Okay, so let's instead use our formula again. Okay, so you would switch D and A, and then you do the opposite of B and C. Okay, so let's do that. On your test, you'll have to do it by hand, but it won't matter which way. You could do it this way without this A, B, and C way, the systems, but that would take a lot longer. So let's use our shortcut. So why don't you go ahead and write that out. Okay. So 1 over negative 4 minus 0. And then that special matrix, so switch A and D. And then you do the opposite of negative 5, which is 5. And then the opposite of 0 just stays 0. Okay? So that's negative 1, 4. So let's distribute. So 1, negative 5/4, 0, and negative 1/4. Okay? If it doesn't have a name, I always just use A inverse. Questions about that? We're going to talk about later today why we want to find an inverse. But any questions about how we did that? Okay, let me show you how to do it on the calculator. So if you didn't grab a calculator, grab one. So you want to go to matrix and you want to enter in your original one. So that's a 2 by 2. So I got to go to edit. And I want a 2 by 2. So 1, -5, 0, -4. Okay. So you need to edit your matrices. So second matrix. Go over to edit. 2 by 2. So once you enter it in, then remember to do any operation, you need to go back to the home screen. So hit second, quit that second mode here. Okay. And then we want matrix A, second matrix. Now you're just under names. And then the inverse button is right here where matrix is. It's right under math, but you don't have to hit second. So you see the X to the -1, that's the inverse button right there. And then you hit enter. You could change that back to fractions, hitting math, enter, enter. And there's our inverse. Yes, give me one. Okay. And that matches what we got. Yes.
Would I still get some answers if I do that, or do I have to save them?
Yeah, as long as you type it like that, that's okay. Yep. And then just write down fractions. Okay. Anyone needs some help with that?
Where's the inverse button?
It's right under math. It's not second. It's just X inverse there. Where's the second button? If you hit math, enter, enter. Okay. Anybody else? Okay. You will want to be able to do this on your test because we're not going to learn how to do 3 by 3 matrices, like inverses, 3 by 3 matrices by hand. So if you have to do that, you'll need to do that on the calculator. Also, you wouldn't have time to do everything by hand. Like you're going to need to use the graphing calculator just to help save the time. Okay, so let's keep going. All right, so this time we're going to do this by hand. We're verifying that B is the inverse of A. To do that, if you multiply them together, you should get I. And you would need to check AB and BA. You need to go both ways. So I want to show that when I multiply A times B, I get the identity. I get 1, 0, 0, 1. So a 2 by 2 and a 2 by 2 will give me a 2 by 2. So first row, first column, 1 times -9 is -9 plus 5 times 2, which is 10. Okay. First row, second column, that's -5 plus 5, right? So I'm doing 1 times -5 plus 5 times 1. And then second row, first column. When it says don't use a calculator, you can use the calculator for your calculations, like just the multiplying part. It just means don't type this into the matrices and do the matrix multiplication on your calculator. So -2 times -9 is 18, plus -9 times 2 is -18. And then Second row, second column would be 10 plus -9. Okay, simplify that. So -9 plus 10 is 1. -5 plus 5 is 0. 18 plus -18 is 0. 10 plus -9 is 1. Okay, so that worked. Now you have to go the other way. So you have to do B times A. Okay, so sometimes it's helpful if you were to just rewrite these where B was first so you don't get confused. But we're doing B first, so now we're doing rows of B and columns of A. Okay, because it's B times A. So -9 times 1 is -9, plus -5 times 2, -2 is 10. Okay, and then first row, second column, -9 times 5 is -45, plus -5 times -9 is +45. Okay. And now second row, first column, 2 times 1 is 2, plus 1 times -2 is -2. And then second row, second column, 2 times 5 is 10, plus 1 times -9 is -9. Okay, then you simplify and you get 1001 again. So that verified they were inverses. Now, the only time that you'll get the same thing if you switch the order A, B, and B, A is if they're inverses. If they were not inverses, then the order matters. Multiplication, matrix multiplication is not commutative. That means you'll get different products. Even if you can multiply them, you will get different products depending on the order that you multiply. Questions about that? Okay, so let's see why we want to find inverses. So we can use inverses to help us solve systems. And this is, I think, the fastest and easiest way to solve systems. So the first thing we're going to want to do is to write as a matrix equation. So we first take our coefficients. So my coefficient sets numbers in front of the variables. So A, matrix A, is 0.3, 1.1, -0.5, and -2.9. Okay, matrix X is my variable matrix. I have two variables, X, Y, and that does need to be in a column. So 2 rows, 1 column. So A times X equals matrix B, which is my answer or my constant matrix. So 3.5 and -10.1. Okay? So I have to be able to write that part out. Are we good with that? Everybody see where I got my numbers? Okay. So what it's saying is that ax equals b. A times x equals b. And we want to solve for x because I want to know what those variables are. So if I were just looking at this equation, ax equals b, how would I solve for x? How would I get x by itself? What would I do to get x by itself? Divide by a. Okay. Well, we don't really have matrix division. So if I did divide by a, why does that cancel? Because a divided by a is 1, right? So I'm really just trying to get 1 here and then x. So in matrix terms, 1 is the identity. 1 is I. So I'm trying to get I. Well, I know I can get I if I multiply by the inverse. So I can cancel a if I multiply it by its inverse. So I'm going to do that on the next step because you have to do it to both sides. And it matters because remember I said matrix multiplication is not commutative. You have to do the A inverse part first. You have to do A inverse times B, not B times A inverse. Because the columns and rows wouldn't match up if you did it the other way. So that is what will cancel the A. So x is A inverse times B. So then I will solve for x, and I will get this 2 by 1 matrix, and that will tell me what the variable x is and what the variable y is. So let's do this on the calculator. So what you need to type in is matrix A and matrix B, and then you'll type that. Then you will go back to your home screen and type in A inverse times B, and that will give you your solutions for x. So I need to edit, so I can type in matrix A and B, 0.3, (1.1), negative 0.5, and negative 2.9. Okay, so there's A, and then go back to edit, so you matrix edit, so you can type in B. B is a 2 by 1, so 3.5 and negative 10.1. Okay. All right, now we need to type in A inverse times B. So I'm going to type in A inverse times B. So I got to go back to my home screen. So second click, and then go to matrix to call up A inverse. Don't forget the inverse part because otherwise you won't get the right answer. Times. Now you want matrix B. A inverse times B. Hit enter. And there's x and y. So you should get negative 3, 4. Okay? That tells me x is negative 3, y is 4. So my answer to this system is negative 3, 4. Okay? So if you go back up, and you look at this system, so these decimals and you have negatives, nothing very nice. You would have to do elimination or substitution. Okay, it would take a little bit of time. So this cuts all of that out. Type in matrix A, type in matrix B, A inverse times B, there's your answer. That's your x and y. Yes? Anybody else have a question about this? Okay, This is what I would call here, like step 2. So if you used your calculator on your test, okay, then you need to show this work. I need to know that you understand how you're getting x by itself, that you're using the inverse to do that, okay? So everything that I have written down is what you would need to write on your test. Yes?
On the test, is there a calculator and
No, there is the test is all together, okay? But there are parts that say by hand, and so on those you would need to show your work. So like on finding the inverse of a 2 by 2, there is a question that says do this by hand. So you have to do the 1 over AD minus BC. And then if it doesn't say by hand, then you can just use the graphing calculator. And you're going to want to use it because it's going to save you time for one. And then, like I said, we don't do inverses of 3 by 3 without by hand. Like you'll need the graphing calculator for that. Okay? Okay, so let's talk about sometimes getting a error message. So I'm scooting this over so I can see when I type that in. So I'm going to call this A, X, and B. So to get rid of A, I multiply both sides by A inverse. And the A inverse has to be written first. Are you almost done? You're going to go back. Okay, so let's type these in. So edit. Okay, and now B. Okay, then you want to do A inverse times B. You know, on the graphing calculator, if you're at the home screen and you hit second enter, it'll bring up the last thing you typed in. So sometimes that can save you some time too. Okay, so you hit enter and then you should get this error message. So that says singular matrix. So first of all, if you're solving the system like this and you get an error message, then you can say, okay, no solution. Okay. The reason why it's no solution is because A is a singular matrix. We're going to talk more about this in just a second, but meaning A does not have an inverse. The reason why A doesn't have an inverse is because if you do AD minus BC, you get 0. So you would be doing that 1 over 0, and you can't do that. So that part you would get stuck. So you would have to stop at that point if you're doing this by hand. Okay. All right. So we're going to talk about what AD minus BC is, and it's called the determinant. So the determinants are used to help us find inverses and for some other things. This says AD minus CB, but it's the same thing as AB minus BC. Okay, the order doesn't matter. So the part of the inverse equation for a 2 by 2, and this is just for a 2 by 2. So remember, this was the inverse. So this part right here is the determinant. Some notation. If you're asked to find the determinant, it's either going to say DET matrix A, or it's going to have just bars around A, not brackets, bars. So with matrices, this is not absolute value. Okay, those bars do not mean absolute value with matrices. Well, can you just go ask and come back down and go there? Okay, so for this example, we want to find the determinant. So determinant of A is AD minus BC, or CB, remember that doesn't matter. So -2 times -1 minus 0 times 5. That is 2. So determinants are numbers, real numbers. You're just going to get a single number when you're finding the determinant. So a singular matrix occurs when the determinant is 0, because remember, you can't divide by 0. That means there is not an inverse. Okay. And then if we look at this example,
when it says the determinant at the top, is it AD minus CB or BC?
okay, so it doesn't matter.
Oh, okay.
Yeah, it doesn't matter. AD minus BC or CB, doesn't matter where when I multiply those. Okay, so on this one, this says find the determinant of the B if B equals this. Well, this is not possible. Why do you think it's not possible to find the determinant of that? Yeah, it's not a 2 by 2. It's also just not square. So you couldn't use the formula if it's a 3 by 3, but you could still find determinants if it's a square matrix. So it's not possible because B is not a square matrix. And again, what do I mean by square matrix? Yes. Yeah, same number of rows and columns. So 2 by 2, 3 by 3, 4 by 4. We are going to learn how to find determinants of 3 by 3 matrices, but not by hand, but not inverses of 3 by 3 matrices. So the determinant process for 2 by 2s is really easy, just AD minus BC. Okay, the determinant process for 3 by 3s is actually pretty long. You're not just doing the diagonals. It takes some time to actually work that out. So we're not done, but we're not going to do that part until Monday. But we're going to go ahead and do this last problem here. So we're going to use inverse matrices again, and solve this system. But this time it's a 3 by 3. So you know how to do this. First of all, just with elimination. You have to do elimination like 3 times. We have also done that in this chapter using the augmented matrix and triangularizing. Okay, so we've also done that. Both of those take a while. This inverse matrix method does not take that long, but you do have to write out your process. So you want your coefficient matrix. So 2, -3, -2, 1, -1, 2, 3, 2, -1. So that's your matrix A. You want your variable matrix. This time there's 3, x, y, and z. And then you want your answer matrix, which is 7, -5, 11. Scoot that over so I can see it to enter in the calculator. Okay, so AX equals B. So multiply by A inverse. Okay. Okay, so same thing. So second matrix over to edit. This time A is a 3 by 3. Okay. And then I need to enter B in. And B is now a 3 by 1. Okay. Go back to your home screen and do A inverse times B. Hit enter, and there you go. Pretty nice, right? It's a lot faster. So if any of you have to take the ACT one more time, and you have something like this, now you have a faster way to solve. So my solution is 2, 1, -4. Okay. So we'll do determinants of 3 by 3 next time.